Okay, so fraction exponents and radicals are actually the same thing. So I'm going to start by talking about a radical because I think that's something that we're all kind of familiar with. And so I'm going to name some of the parts of the radicals. So I think this is good for you to jot down and make sure that you feel comfortable with the vocabulary that we're going to be using to describe radicals or roots. Okay, so we're going to talk about radical and root notation. I think when people see what's up on the screen right now, you're like, oh yeah, that's a square root, right? Generally, that's what people are going to answer. It actually has a name. That symbol is called the radical symbol. And so when we're referring to radical, we mean this actual symbol piece right here, radical. So when I say like, make it look like a radical, you want to have that symbol. Bless you. Now, the most common radical that we're used to working with is what type of root? A square root, okay? So let's just talk real quickly about a square root. I'm going to put this off to the side. You decide, it's your notes. Okay, it's most common. It's often written as just simply the symbol, the radical, right? So I'm just going to put like an X in there. It could be anything. But it's often just written as square root X. It actually has a number out here. So you see on my notation I have this N. This is called an index. So it's the index of the radical. And it tells you which root you're actually trying to find. So the square root is actually something that looks like that. Like there is a 2 out there. It's just that it's so common, we use it all the time, that then we just dropped off the 2, the index. And when you see a radical without an index, you just assume it's square root. So don't be confused if you ever notice, like in the textbook, they might sometimes put a 2 out there. It's still the same thing, it's a square root. But we've also seen other ones, like we've seen cube roots before, right? Where you would have a 3 out there instead. Okay, so we're going to have cube roots, 4th roots, 5th roots, 6th roots, and I'm going to call this one right here, because it's n, I'm going to call it the nth root. So down below, I'm going to make a little note. I'm going to put this in quotes. This is the nth root of A. That's how you read that. We want to be able to talk like mathematicians, so I'm going to ask you like today to practice saying those types of roots. The 4th root, the 5th root, the 6th root, the square root. Instead of saying things like radical 2. It's not really a radical 2, it's a square root of 2. We'll practice talking like the mathematicians. Okay, when we talk about nth roots, what we mean to say, if we're saying like the 5th root of the number, we're trying to say like what number multiplies by itself 5 times, right? Because that's what a square root is. What number multiplies by itself 2 times? So cube root, what number multiplies by itself 3 times, etc. Now, before I leave this notation on radicals, I'm going to talk about the thing that's under the radical. In this case, it's A. That does have a special name in mathematics. I always think it sounds kind of funny. It's called the radicand. So the radicand is the thing underneath the radical. Sometimes in class I'll say like the number under the radical or the thing under the radical, and then sometimes we might say the radicand. So make sure that you feel comfortable. If you hear the word radicand, you know it means the thing under the radical. And radicand. Okay. a connection between radicals and rational exponents. So now we're on this slide, we're going to talk about the connection between radicals and rational exponents. And we should be able to rewrite. They're really the same thing, so they're just like two different forms. We're going to be rewriting radicals and rational exponents. What did we all agree to on that first slide? Rational exponents really just means fraction exponents. Okay. So, radicals are fraction exponents. I'm going to make a little cheat sheet over here on the side. The square root of x, which you could put the 2 there or you could not put the 2 there, is really x to the 1/2. And the cube root of x is really x to the 1/3. And the fourth root of x is really x to the 1/4. And then I'm going to say like dot, dot, dot. The nth root of x is really x to the
1 over n.
1 over n.
So if you had like a 1 outside the radical, would it just be like x itself?
Well, a first root we don't really
Even right in there. So it'd be like the
you
number
can't multiply a number but with only one number. So remember, what does a square root mean? What's the number that multiplies by itself 2 times? So you wouldn't have a number that multiplies by itself 1 time, because then that would be a square. No first roots.
Talk about how when a number has an exponent of 0, that makes it 1. What if the index is 0?
There won't be a 0. So let's say the smallest root you can have is the square root for n greater than 1. No 0 roots. Because then 1 over 0 would be undefined, and that would be a problem for us. Okay, now let me ask you this. In the fraction exponent, where is the root? In the denominator. So I'm going to make myself a little note here. The root is in the denominator. If there's one thing you can remember from this very first day of notes, it's that the root is in the denominator. So when you're practicing your homework this weekend, you be saying that to yourself, root is in the denominator. That's where it belongs. If it's in the denominator, then it is the root. Okay, it works both ways. Now, I'm going to make things just a little bit more complicated. I'm going to say, what if I had the nth root of x, and I raise it to the m? Oh, this is bad. You guys are being dramatic. Yeah. Yes. Okay, so I'm going to do a little bit of work here. Do you agree that the nth root of x is just x to the 1 over n?
I'll put the m outside the parentheses.
And then it's being raised to the m. Properties of exponents, what are you supposed to do with power of a power? Multiply. M times 1 over n is just m over n.
Because 1 times m, Megan.
An exponent. No, it's an exponent. I'm raising it to the m. Now, that can be rewritten a couple of different ways. So, the same thing, I'm going to say same as. Sometimes you see it written where they take an nth root of x and then they put it in parentheses and they raise it to the m, but that's going to give us the same thing. Still going to be x to the 1 over n raised to the m, and then you multiply. So that's also equal to x to the m over n. And then sometimes you'll see it as the nth root of x raised to the m. So what if the exponent is down in the radicand? Oops, sorry, I meant to go the other way. Sorry. Then, in this case, you're doing x to the m raised to the 1 over n, which still multiplies to give me, oops, I wrote 2, didn't I? Is that why you guys were laughing?
I'm still trying to talk.
going to do it again. X to the m over n. Yes, Quinn.
So when it says like when it has the exponent, the first one that's like x to the 1 over n to the m.
Uh-huh.
Are we multiplying
Yep.
the m and the n?
Mm-hmm. Power over power property from algebra 1.
So we're multiplying 1n.
1 over n times m over 1.
Okay.
All we're just saying
Okay, now remember, we had said earlier that over here, when we were doing the simple ones where it was just a root, that the root was in the denominator. That holds true over here, right? So if you're raising it to some exponent m is going to be a regular exponent in the numerator, n is going to be in the denominator. So the thing is still true. N is in the denominator. Root is in the denominator. Okay, so on the next slide, we're just going to practice rewriting. We're not going to evaluate yet. We're just going to practice rewriting. Suppose I give you the square root of 11 raised to the 5th. And all I want you to do is to write it as a rational exponent.
start with out there.
Yeah, you can put a 2 out there if you want. You see that it's what root?
Square.
The square root. So if you want to put the little 2 out there, that's totally fine with me. So we're taking the square root of 11 and we're raising it to the 5th. And all I'm asking you to do right now is rewrite it. So it's in radical form. Let's write it as a rational exponent, which just means a fraction exponent. We've identified the root is 2. Where does the 2 belong? The denominator. So what's my fraction exponent?
5 over 2.
11 to the 5 over 2. Done.
That's going to be like hard for you to say. Like, so like 11 to the 3rd power, 11 to the 5th over 2nd power.
I just say 11 to the 5 over 2. I don't really worry about it. Okay. All right. What about 6 to the 2/3? Now I want you, it's in a rational exponent. It looks like a fraction exponent. Let's write it as a radical. Okay, what root are you taking?
Third.
Third root. Cube root. So that's the cube root of 6. And then it's squared. Hooray. I mean, it could be written as the cube root of 6 squared, which would be the cube root of 36. They're the same thing. Let's actually practice some let's practice some calculator stuff in our calculators right now. So first off, I want you to practice 36 to the 1/2. Okay, these are some various exponent buttons around the room. Okay, some people with my little TI 30x2s, you're going to have something that looks like a caret. That means raised 2. Okay. Some people have a button that looks like y to the x. That's your exponent button. Some people, like the Casios, it has like boxes like that. Exponent button. Now, if you don't have like a math print function where it like actually looks like it's in the exponent, when you write this in your calculator, you have to do 36 raised to, and then you have to do parenthesis 1 divided by 2. So try that in your calculator.
You have to put the
You'll hit math. Oh, it doesn't like raise it to an exponent. Yes, you probably like it.
So it doesn't look like that.
So I would leave it on. Yes.
I got 6.
And that should be equal to 6, right? We're going to do roots in a minute. Can you do 36 to the 1/2? Okay. Anybody else having trouble? Why did the x button? So I don't know. You might have to do, I think, try typing 36. And then do the y to the x button. And then you might have to do parentheses first. So parentheses 1 divided by 2. And then close the parentheses. Now that's just your parentheses, so hit equal. Anybody else? I think it's got it working. Yep. Yep. You're gonna need your parentheses. Okay? Are you guys okay? Okay. Now let's try something. Let's do a root. Okay. So you guys know where your square root is? Let's do one that's not a square root. So let's do a fifth root of 32. Okay. Most people, but not everybody, the newer versions, you might not have to do this. Most people, you have to type 5 first, like tell it there's going to be a fifth root. And then you're going to do seconds and whatever your exponent button is. So mine was the caret button. And then what it brings up is something that looks like this. It has like a little X on it, but you have to tell it that there's a 5 there. I'll be with you in a second. Okay, and then you can type in 32 and tell it to enter. You are going to go to, you're going to type your 5 in, and then you're going to do math. And you see it right there. You got to fit. You are going to type in your 5, and you're going to hit enter right under your green button. There it is. See it? Number 5? Yep, it should equal 2.
Well, you could just put the you do 5 first, right? And then you do well, you don't have to put the carrot. You just do 5 and then second. I was doing just the right balance.
Hold on, it says solvers. Equation. It says equation solver. 0.
Did you find it?
Hold the.
2. So you might have to do, try, you have a button that looks like that with an X on it. X to the 1 over Y. Okay, try typing in 32, and then try hitting that button, seconds, that button, and then try typing 5. Anybody else? Okay, you should have gotten 2. Okay. Now, these don't come out nicely, so we're just practice rewriting them, but you could get a decimal right in your calculator at this point. Okay, now we're going to take a little bit of time to make a nice little chart in our notes. So this is going to be a chart. We're going to have 1, 2, 3, 4, 5, 6 columns. And I'm going to go from the numbers 1 to 10. I'm going to do 6 columns and then 10 rows below them.
Yeah, I know. How many do you want for each number? Do you want 2 lines or
1. You're just writing a number in it. 1, 9. Okay, we're going to list the perfect squares. To get the perfect squares, we're just going to take all these numbers in the root column and square them. So we already know what the perfect squares are, right? Okay, 1, 4, 9, fill in the rest. Okay, we know some of the perfect cubes. 1, 8.
64.
Good.
125.
Awesome.
100. No, I got this.
216.
343.
343.
What are you doing?
I don't think I gave you 8 or 9, but let's just put them down so we've like seen
15
them
is
once.
225. No, it is not 225. Never mind.
That's 15 squared.
Yeah, it's 15 squared.
oh,
What's 8 cubed?
512.
512. 9 cubed is 729. And then the tens are easy, right?
1,000.
It's going to have 3 zeros because it's being cubed. Okay, now I'm not going to fill in as many fourths, perfect fourths, but I'm just going to go back to this root column, and I'm going to raise these numbers to the fourth. I think I'm going to go to about 6. So 1 to the fourth, that's easy, right? 2 to the fourth is just 2 cubed times 1 more 2, so that's going to be 16. 3 to the fourth is 81. I think about it like this. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. 4 to the fourth is 256. You could use the same method, 16 times 16. You might know from Pythagorean theorem. Just to be familiar with it, 5 to the fourth I think is 3,000. No, 625. I'm jumping ahead. 625. Sorry. And then 6, I recognize every now and then 6 is 1,296. But that's about as far as I know for perfect fourths.
Yo,
And
you
then
know what's
10.
whack?
And then 10.
Whack. The numbers in the second one are the fourth ones too. You have 2, 5, 6.
So if you want to fill in 7, 8, and 9, that's fine. But I'll tell you real honestly, I don't even know what they are. It's just nice to be able to recognize some of these smaller ones so that you don't have to do everything in your calculator. Okay, let's fill in some perfect fifths. This is going to be 1. We already know this one because we just did the fifth root of 32. It's 2. So 2 to the fifth is 32. This is going to be 243, 1024. Can someone check 4 to the fifth for me? And then I know 5 is 3,125, and then of course I know 10. 5 zeros. So 100,000. Okay, and then I'm going to do some perfect sixths. That's going to be 1, 64. Is this 729? I think.
It would be, yeah, it would be.
Yeah, I don't know any of the other ones, so I'm going to jump down to 1 million.
Well, you know what you can look at too, which is
Yeah?
crazy. I don't know why, but like it was 9 was 729. So
Mhm.
3, 6, because 3 doubled is 9.
Oh, yeah.
So you get 729.
It's like 3 times 3 times another 3. Okay, yeah, so like these are just nice to like have seen these numbers before, and if you see them under a radical, you're like, oh, I do know the fifth root of 32 is 2. So some people will jump on board a little bit faster than others, but I would say like look this over, try to do some thinking about some roots in your head without jumping straight to your calculator every single time. See if you know the roots first. Okay. Now, you could use this table like this without a calculator. If I said, what's the fourth root of 256? Go to the fourth column, find 256, and its root is
4.
4. What's the sixth root of 64? 2. Go to the sixth column, find 64, its root is 2. If I said, what's the cube root of 20? It's not on there. We know it's somewhere in between 2 and 3, but then we might use our calculator to get a decimal, right? Okay. So let's simplify these expressions. I'd write these down in my notebook. 81 to the 1/4. I'm going to ask you to do this. Remember that we're trying to make a connection between fraction exponents and radicals. So let's write these fraction exponents as radicals and try to avoid our calculator if we can. So 81 to the 1/4 is asking us to do what?
If you put 4.
Use your mathematics language. The what root?
4.
Fourth root of 81. Say that out loud. Fourth root of 81.
4 through 81.
Yes. Okay, what is the fourth root of 81?
3.
One quick announcement, excuse me, this is Mr. Van Akron. All freshman boys basketball players pick up a picture packet from Coach Brown before the end of the day. Again, all freshman boys basketball players need to pick up a picture packet from Coach Brown before the end of the school day. Thank you.
Okay. Whoa, I threw something crazy out here. So we're going to have a little conversation.
It's negative.
16 to the negative 1/4.
Oh, wait.
What do negative exponents do?
Screw everything up.
That would be if you take like a square root of a negative number. But that's not necessarily a negative exponent. Negative exponents aren't polynomials. Neither are fraction exponents. So we're not talking about polynomials anymore.
Let me write this one down.
Okay, negative exponents don't make anything negative. If you need to write that down right now, write it down. I'm saying it out loud, and you can copy my words. Negative exponents don't make anything negative.
Negative exponents don't make negative.
Negative exponents
Don't
make anything negative. Negative exponents flip what they touch. Negative exponents flip what they touch. So if you want to write that down. Negative exponents don't make anything negative.
Flip.
Negative exponents flip what they touch. Okay. So what it normally means, like if you had, I'm going to do it without a fraction. If you had 2 to the negative 3, the negative exponent is touching the 2, so the 2 flips to the bottom.
What?
And becomes 1 over
That just
2.
like blew my mind.
It makes it into a fraction. So see, negative exponents don't make anything negative. Okay, so what will the negative do to our 16?
It's gonna flip it into a fraction.
It's going to be 1 over
16.
16. Now it's to the positive 1/4. I'm just going to do one step at a time because these are my notes. So that is me knowing about a negative exponent from Algebra 1. Your Algebra 1 teacher told you that. Negative exponents don't make anything negative. They flip what they touch. Now your Algebra 2 teacher is telling you that 16 to the 1/4 means what?
16 to the negative.
1 over
4.
the,
Fourth.
say it, the 4th root of 16. And then what's the 4th root of 16?
1 over 2. Checking. Well, I'm using my chart right now. So
Okay, look at your answer. Is your answer negative?
No.
No, because negative exponents don't make things negative. Can you tell that might be a tough task for some people to remember? So I'll say it's 20 times. Okay, let's try 4 to the 3 halves. 4 to the 3 halves. We're going to try to do it without our calculator if we can. We're building a connection between rational fraction exponents and their radicals.
At least it's not negative.
Yeah, it's not negative. So there's no flipping. Where is the root in your exponent? The denominator. So what root are we taking?
Second.
The square root of
4.
4
Versus 2.
raised to the third. And then I hear some people telling me the square root of 4 is
2.
2. And 2 cubed is 8. Don't even need a calculator for that, okay? Now, you could have done that as the square root of 4 cubed. What's 4 cubed?
64.
64. What's the square root of 64?
8.
8. So it doesn't matter if you make it small and then you raise it to the third, or if you raise it to the third and then you make it small by taking the square root, you're going to get the same answer. 2 cubed. Square root. I don't don't have to write the 2 there. You can if you want to. But then we all accept that's a square root, right? So the 2 is there even though I'm not going to write it. Okay. 8 to the negative 5/3. You're saying to yourself what right now? Negative exponents do not make anything negative. They flip what they touch. Thank you, Katie. So what's going to flip? 1/8 to the 5/3. So you're not flipping your exponent. You're flipping what it touches, which is 8. It drops to the denominator. Unless there was something underneath it, but generally yes. Because like 8 is 8/1. Unless it was a fraction, I guess. Is what I'm supposed to say. What does 8 to the 5/3 mean? Say it out loud. Fifth roots?
No, third root.
Cube root.
Cube root of
8 raised to the 5th
8
power.
raised to the 5th. Now on this one, I don't know what 8 times itself 5 times is, but I do know it's a big number, right? Like 8 cubed is already 512. So I'm not going to make it bigger. This time I'm going to make it smaller. Cube root of 8 is
2.
2. So that's 1/2 to the 5th, which is
32.
1/32. Okay? Now, is your answer negative? No, because negative exponents don't make anything negative. It's beautiful, the sounds you're saying to me, okay? Anybody got any questions there? Now, if you find out those numbers are not on the chart, then you might have to, if it's asking you to evaluate, you might have to type into your calculator and get a decimal answer, okay? Okay, last topic. Write this down. Last topic. You got this. It's Friday. You got this. Brand new chapter, brand new chance. Woo! Start fresh. You got this. Okay, we're going to be solving equations in the form x to the n equals a. So x is your variable. It's like the thing you want to find. It's being raised to some n. It could be any n. It could be x squared. It could be x cubed. It could be x to the 4th, x to the 5th, x to the 6th, so on and so on. And it equals some value a on the other side, whatever that may be. And so my directions to you are to undo that exponent n, take the nth root. It's what you did with Pythagorean theorem, right? When you got to c squared equals 36, took the square root of both sides, and c was equal to 6. So now if it's c cubed equals 8, you're going to take the cube root of both sides. And c is going to be equal to 2.
Yeah, that's
Okay, and if it's c to the 4th equals 1, take the 4th root of both sides, and c is equal to 1. There's a little bit extra that we need to make note of. If you take an odd root, there is one answer. I'm going to write 2 equations. We're going to solve them. These are simple. X cubed equals 8. I want to get x all by itself.
you gotta isolate it. Okay?
It's being raised to the 3rd, so I'm going to cube root both sides. And what is the cube root of 2? What number multiplies by itself? Or sorry, cube root of 8. What number multiplies by itself 3 times to give you 8?
Okay,
2. Now, when we did square roots in chapter 3 and in chapter 4, you would always have to add what? A plus or minus. So let's think about this. 2 times itself 3 times. 2 times 2 is 4 times 2 is 8. It works, right? What if it were negative 2? Negative 2 times negative 2 times negative 2. Negative 8. Not the same thing. So there's only one answer. 2 is the only one that works. If you had x cubed equals negative 8, then you can cube root both sides And your answer is
-2.
-2. Note that if you're doing odd roots, you can take odd roots of negative numbers. You don't have any i's, right? The cube root of -8 is just -2. So it multiplies by itself 3 times to give you a negative.
Oh.
So it's fine. Now, if it's an even root, 2, 4, 6, 8, 10, so on and so on, you're going to have 2 answers. That's when you need to add the plus or minus. So I'm gonna go x to the 4th equals 16. If I did x to the 4th equals 16, I would take the 4th root of both sides. Okay. And I'm thinking about the 4th root of 16 is plus or minus 2. I know that because it's even, but let's just work that out. I mean, obviously 2 times 2 is 4, times 2 is 8, times 2 is 16. So let's work out the negatives. -2 times -2 is 4. Times -2 is -8. There's that odd exponent going to a negative. And then times -2 is positive 16. So -2 also works for this. So x to the 4th equals -16. We actually can do. It's going to be imaginary. Is there a real number that multiplies by itself 4 times to give you -16?
Nope.
No, because an even number of times is always going to be positive. So we're going to come up with x equals plus or minus 2i. Okay? So last thing, just a few quick examples so we can kind of run through this. You'll be asked to do this on your homework assignment. Let's solve. Could be something as simple as this. X to the 5th equals 32. Your job is to isolate x. Get x all by itself. If it's being raised to the 5th, what are you going to do? Take the 5th root of both sides. Thank you for using your mathematical language here. Take the 5th root of both sides. What type of root is that? Odd or even? Odd. How many answers for an odd root? 1. What is the 5th root of 32? 2, because it's positive, my answer is going to be positive. Okay, check it. 2 to the 5th equals 32. Works. Okay. Next one. 5x to the 4th equals 80. 5x to the 4th equals 80. Your job is to isolate x. What are you going to do first? Divide by 5. Don't 4th root it until you've got like that x to the 4th as much alone as you can. So we're going to divide by 5. That's going to give me x to the 4th equals 16. How will I get rid of x to the 4th?
Use the 4th root of x.
Use the 4th root on both sides.
Yeah.
And is that an even or an odd root?
Even.
Even, so I'm going to have
Plus or minus.
plus or minus 2 answers. Okay, now you could check that, like 2 to the 4th is 16 times 5 is 80. And then negative 2 to the 4th is also positive 16 times 5 is 80. Did I say 90? In my head it sounded like a 90. Okay. What are you going to do for x is 6 minus 50 equals 14? Add 50. X to 6 equals 64. Take the 6th root. Plus or minus because it's even. There's 2 answers. Equals plus or minus 2. Okay. All right, my last one. Am I close to that little X? Oh, I got it. Okay, quantity x minus 1 cubed equals negative 8. Can I add 1 right away?
No.
No, it's trapped in that parenthesis, right? So I got a cube root both sides to start with. I might worry about taking a cube root of a negative, but since it's odd, no worries, right? I don't have to worry about what's my answer there? Cube root of negative 8. Negative 2. That's just equal to x minus 1. So then add 1 to the other side, and x equals negative 1. Check it. Negative 1 minus 1 is negative 2. Negative 2 times itself 3 times is negative 8. Have an answer. So you have a homework assignment on your goal sheet. You should work on it. I want you to practice as you're doing your homework, saying things out loud so that you can talk like mathematicians, right? So I want you to say like, oh, x is 6 equals 64. 6 root of 64. And then ask yourself this question. Even root plus or minus. Hang on.